Functions, normal functions like we've been talking about, y equals mx plus b, linear functions. That's your common type that we've hit so far. Special functions, the first special function we're actually going to talk about is one called a piecewise function. Just like it sounds, it is pieces of several functions. And so when they give you a piecewise function, they actually split up the domain here, and they tell you which pieces go with which x's. So like this first piece they give us is x plus 3. That's actually just a line. Y equals mx plus b. That's a line. But they only want us to do that line for every x value that is less than -2. So you'll see that we have x equals -2 right here. And we have that piece of our function on the left side, less than -2. All right? The next piece of the function is this x squared. Well, y equals x squared is a parabola. But they only want that from -2 to +2. And so you will see that we have from -2 here to +2 here. And we do have this parabola, which is that piece of the function. That's a piece. All right, and then the final piece that they have here is just 1. Well, y equals 1 is actually a line as well. It is as you can see, a horizontal line, and they only want that to happen for 2 to 5. And so you'll see that we have from 2 until 5, and we have this piece of the function here. And so it is a piecewise function because it literally breaks the function up into pieces, all right? You'll notice some open holes and closed holes like we have done in the past. You'll notice this is only less than, it's not less than or equal to, so you'll see that at the 2 we have an open circle. This guy is or equal to on both ends. So -2 and +2 have closed circles here. And then this guy is open circle here, closed circle here, because it's just less than or equal to, open circle, closed circle. And so you follow the same rules, but you're only graphing a piece of each of those functions that they have given us. And so your domain will change depending on what piece you're in. You can have different domains, all right? And you'll see that on the other one, we had 3 different domains, really. And these are all examples of piecewise functions. For this first one, my domain is going to start at this x value right here. And it's going to go to this x value right here. Well, this x value right here is -4. So it starts at -4, and it goes all the way to +3. Does it include -4 and +3, and how do you know? Does it include it or not? Yes, it includes it. How do we know that? The circles are closed. This is a closed circle. This is a closed circle. So I know it includes it. So I know I'm going to have or equal to, and x is really everything in between it. So x is in between it, and it's going to be or equal to's because it includes it. All right? This next one actually jumps. It doesn't include every x from start to finish. This first piece is all the way over here. Right at 1, 2, 3, 4, 5, 6. So we're at -6 there. But it only goes up to -1 for this piece of it. So it goes to here, to -1. Does it include the -6 and the -1? Open or closed circles there? Closed, so it includes it. But then we are going to combine that. We can use our little union symbol there. And it jumps over to +2 and goes from +2 until +4. All right, and so we have another piece of this from +2 to +4. Does it include those? It includes 2, so it is or equal to there, but it does not include that one, so we would just do a less than sign. Everybody see what I'm doing here as far as these domains go? Visually, it's really easy to see. All right, so where does this one? This goes from here to here, right? 1, 2, 3, 4. We go from negative 4 to positive 1, right? But it starts again at positive 1 and goes all the way until positive 5. All right? Now here's the thing. It includes both endpoints here, right? But it doesn't include it here. But if I am union these, putting them together, do I need to split it up? Technically, it goes all the way from here, all the way to here. Does everybody see that? Because it includes it. This function, even though it doesn't include it at this point, it does include it here. So technically, it includes 1. So for this one, I could actually just go from negative 4 all the way to 5. Because I actually don't jump. Here I jump. I actually have a space. But here I don't jump. I jump in the function for the y value. It's not continuous. But the x value doesn't jump there. You actually keep going. So for this last one, you can actually just write it like this. You don't have to do a union between the two. All right, this is 3 different lines. My first line is y equals negative 3. Y equals negative 3. This is a horizontal line. Just goes across horizontal. But I only do that line from negative 5 to negative 2. My y value will always be negative 3. So at negative 5, I go to negative 3. And does it include that point at negative 5? Yes or no? Does it include it, the negative 5? Is there an or equal to? Yeah, there's an or equal to, right? Negative 5 is less than or equal to. So we go here. At the negative 2, though, it is open. And so that is my first piece right there. Horizontal line. My second piece is a different line. Y equals x plus 1. All right. So for this one, from negative 5 to x to negative 2, my y value was always negative 3. But now I'm going to go from negative 2 to positive 1. So now I have to figure out what my y value is. Okay. So let's figure out my y value. My y value at negative 2 is what happens when I plug it in. Negative 2 plus 1. What's my y value there? Negative 1. All right, that's my 1 point. Does it include that point? Yes. So at negative 2, negative 1, I have a closed circle. All right, let's look at the other end, okay? Positive 1. What happens when I plug in a positive 1? 1 plus 1, what's my y value? 2. So at 1, 2, is that going to include it or not? No, open circle. And then I just connect those dots. That's my next piece. Easy enough? All right, let's look at the third piece. My third piece is y equals negative x plus 4. And I'm going from 1 all the way to positive 4. All right, let's see what happens here. I plug in a 1. Negative 1 plus 4 gives me 3. Does it include that point? Yes, it does. Closed circle. All right, what happens when we plug in a 4? Negative 4 plus 4. 0. Does it include that point? Yes. It does. 4, 0. And then I connect those dots. That is my function. That is my piecewise function. I just graph each piece of it. All right, and you can do that by graphing your endpoints because these are all lines, right? And then you can just leave it the way it is. Make sure you do open or close depending on whether it is or equal to or not. An absolute value function is a type of piecewise function because you have the positive side of it and the negative side of it. So you're basically putting two lines together. In fact, when we solved absolute value equations, that's what you did. You said the inside equals the positive and the inside equals the negative. And so that's how you even solved absolute values. So they look like a V because they are literally two lines that mirror each other. Okay? They mirror each other. You have this guy right here, which is just the y equals absolute value of x. This is called the parent function because you have groups of functions that follow these parent functions, and you can shift them around the. So when you have an absolute value equation and then you add something on the outside of it, it's going to take that little v that you had, the perfect slope, one slope v, and it is going to move it up or down. If you're adding up, if you're subtracting down. When you have something on the inside of the absolute value, it's actually going to move it left and right. But on the inside, it does the opposite of what you would think. You would think negative here would move you left. It doesn't. It would actually move you right. So when it's on the outside, it goes up and down exactly how you think it would be. Positive up, negative down. When it is on the inside, it moves it opposite, left and right. Positive left, negative right when it's on the inside. So let's look at these two graphs here. All right, this first one, I am going to do the V. So normally my V would start right here, right? And I'm just going to graph the standard one. The standard one would be a one slope here and a one slope here. This would be your standard one. This is just, it's not very visible there, is it? Let's do it darker. This is your basic absolute value equation right here. So this gray one is just y equals the absolute value of x. That's your standard equation. But they've given us a shift. They've said, I want you to shift it up 3. And so when you do that, you just take this one and you're going to start here at this point, and you're going to go your v right here. And so this will be your absolute value when you add 3 to it. It just moves it up 3. That's all it does. All right, let's look at the next one. For the next one, they want us to move it left or right. We're going to take that exact equation that we just did for this one right here, this original one. And on the inside, we have -2, but it's opposite of what you would think. A -2 is actually going to move it this way. And so we're going to take that graph and we're going to move it over 2 and we're going to graph it again. It's just a one slope, up 1, over 1. So that's why you're going straight down those centers there. And so that's how your absolute value moves. On the outside, it moves it up and down. On the inside, it moves it left and right.